Well, that seems to be producing slight variations, but it's quite hard to tell. So let's copy and paste this mantra node and call it mantra medium quality. And in the sampling tab, I'm going to increase my samples to, say, 10 by 10. Now if we select mantra medium, and we'll need to reselect our area of interest, we can see more clearly the effect of that change in the displacement. Well, those reflections are looking pretty good, in fact. I want to change one more thing, because I think the inside is still a bit dark. I'm going to go into where we set up the mug, and I'm going to change the color of the inside of the mugs so that it's actually white. And that starts updating immediately. Let me render a slightly bigger sample. I'm going to pause the video while this renders out. That seems to look reasonably good. Let me just check that we have diffuse bounces enabled. And in fact we don't, which is one of the reasons perhaps the scene is a bit darker than it might be. And we can see that's starting to look pretty good. So I think we can leave the shader with those values. Quick look at the shader that we just used. Let's jump inside and have a look at the reflective surface here. The thing that I wanted to illustrate is that the output node of every shader has this component here, f. And this is not a real variable, this is a notional variable which allows the shader compiler to work out what is happening with the lighting on the shader. So in this case our lighting is coming out of 3 inputs, one of which is a Lambert shading node, which produces this value f, which goes into here. The second of which is a specular subnet, which if we dive inside is using a specular node to create f and feed it out again. And then finally there's a reflective node here, which is creating the reflections. So f is the total of these 3 inputs. So in other words, the specular function, the BDSF as it's called, sorry, BSDF as it's called, is made up of the sum of a Lambert component, a specular component, and a reflective component. And because these are wired together, the PBR rendering engine knows about the nature of the specular reflections on the surface, which is very important because it needs to sample the outside world according to the nature of these functions. Luckily, all of the shaders here in the material palette come with the f value constructed automatically. They're all connected. But if you set up your own shaders and want them to be valid for PBR, you need to take the f outputs of your lighting nodes and add them together and feed them into the output. So let's do a final render now, and to do that I'm going to select our medium mantra node, copy and paste it, rename it high for high quality, and then on the sampling tab I'm going to take the number of samples up to 20 by 20. Check these values are okay. So to render our result, I just need to click on this. I'm going to pause the video as that renders through. So this is our final render. It looks reasonably good. There's still a little bit of noise here, so we'd probably want to increase the sample slightly to get a perfect image. It took about an hour and a half to render on this machine. This is a 32-bit Windows machine. It runs about 25% faster on a 64-bit Linux machine, but it's a reasonably good image.